Hello, Mike Canny again, and today we're going to be looking at another quote unquote network issue. This time we're going to be looking at a problem between a web server and a backend Oracle database. And again, as I mentioned, this was a problem that was reported as the quote unquote network is slow. So we've pulled the trace file, in this time PCAP format, again captured with Wireshark, into NetData for further analysis. So likewise, the first step typically is going into the dialog chart. So what we can see in the dialog chart, on the left-hand side, again, are the clients, and the right-hand side are the servers. And we can see we had a fair amount of retransmissions, specifically as it relates to this SOAP server. But what we're going to focus on for this analysis is the back-end database. So the next step I'm going to do, again, I've got my chart menu set to chart out transactions, and I'll right click on the Oracle server and say chart records of this service. So what that's going to give us is just all of the Oracle. Now we see the transactions populated in the performance chart. I just wanted to make a side note again. Some of you may be wondering, well, why are you looking at the backend Oracle database? Why didn't you look at the front end first? Well, quite simply, from the network engineer, they had gotten word from the server admins that there were performance issues on the database, but they weren't really sure why. So that's why we started with the Oracle server. Now, one of the things I'm going to do here is make this full screen so that we can better see the Oracle transactions. And again, something to note here is that there are over 500,000 database transactions plotted out on this chart. So this means queries, fetches, inserts, deletes, commits, etc. Everything is plotted out and sorted by time interval, right? So we can see this band at the top here. We've got markers up here that are indicating transactions that are taking about 10 seconds. And as I kind of mouse over that, you can see a little bit of the description of that SQL statement. And you can see this is a listener timeout waiting for a message, right? So this is a keep alive that probably isn't or doesn't have anything to do with the actual end user experience. So what I'm going to do here is I'm just going to simply right click on this, and I'm going to tell NetData to hide this type of marker. And once I do that, it actually is going to remove that type of marker from my analysis. So what I'll do is I'll repeat this for all these transactions, and starting with the slowest ones first, and then systematically working my way through the actual number of transactions until I get something that actually makes sense from an application perspective. So now what I'm left with is a handful of transactions that completed around 3 seconds. And as I mouse over these, you can see what those calls specifically are. We've got some fetch continuations. But down below, we literally have these bands of markers, solid line around 300 milliseconds. And we've got another band right around 180 milliseconds. So these are things we may want to take a look at. Now I can zoom in to get a clearer view of these hundreds of thousands of transactions that all seem to be taking about the same amount of time by simply right-clicking here and saying set this as the largest response time. And what this is going to do is now rearrange this view or recalculate this view so that I can get a little bit more granular aspect into those transactions that have hundreds of thousands of calls made to them. Now that the zoom is completed, we can clearly see these bands of markers. 300 milliseconds, around 180 milliseconds. Now what's really cool is if I want to look at any one of these specific transactions, I can simply right click on it and then have NetData describe this transaction to me. Now this is really where the power of NetData comes in from an upper layer protocol perspective. It is the finest tool when it comes to understanding what is going on in those upper layer protocols. what is going on with those database calls and the packets that are involved in completing these calls. Now, one of the things that you'll see here is it popped up this window allowing me to save off the SQL statement. Now, what's neat about this is that I can save that actual SQL statement in a text file, then send that off to the developer and say, hey, here's the actual query, fix your code. I'm not going to save this one, but I will have it drill into this specific call so that I can view this either in a tree or a text format. And now that I've drilled into it, it'll allow me to expand what this actual query is. Now I can see that the select, we're pulling back 9 columns from work order accessory where work order equals asterisk, right? So this is a clue for me here. This is my first clue. Now, if I click on this, I can now expand this to see even deeper into this selected query. And as I click on both of the plus symbols there and expand this window a little bit, you can see the depth at which NetData shows me this specific query. And likewise, if I look at the response and expand that and zoom into this, you can actually see the table that is returned. So there's my 9 rows of data that came back from this specific query. The other thing I wanted to point out here too as I close this window is that you can see all of these markers that I selected on now turned yellow. And what that indicates, you can see they've been highlighted, and those are that same call being called over and over and over and over again. So when I described that transaction, it automatically highlighted all of the like transactions. So I could repeat this process, right-clicking, describing the transactions, etc., to my heart's content. But one of the things that I want to do is I want to ask NetData, what do we need to fix in this database? All right, so one of the things that built into this, if I come in and I click on the statistics chart, and I come over here and I say chart transaction mixes, what this is going to do is allow me to see, or in progress rather, this tip, as well as the rate of those transactions. Now I've got a bunch of different bars up here of the same bars, but what this does, if I look at the transactions in progress, you notice that there's percentage numbers by that. There's 30.41%, 23.53%, 4.15%, etc. in the transaction in progress. And what this is telling me is that 30% of the overall database time, or in this case, to be more accurate, 30.41% of the overall database time, was this specific blue select statement. Select 9 columns from work order accessory, etc., where work order is asterisk. That should look familiar. That's the one we just looked at on the performance chart. That was called 15,885 times. The rate, if I mouse over that, again was pretty quick, right? So that transaction on average was 158 milliseconds, right? So that's that band that I was calling around 180. I was kind of swagging the time. But the transactions themselves took 158 milliseconds on average. But due to the fact that they were called 15,885 times, took 30% of the overall database resources. This next one is a select 10 columns from work order accessory, where work order ID. Again, kind of going back to this work order as being the common denominator here. Again, mousing over this transaction on average was taking 39 milliseconds, but again, 23% of the overall database called, in this case, 6,726 times. So what this gives me is a solid data point to take back to the DBA or the developer in this case and say, hey, look, over 50% of the overall end user experience or the overall response time and resources on that backend database are because of two select statements. And guess what? They also have a common denominator of work order ID uh, being the culprit of why this is slow. So again, we nailed it. The fix for this, actually, what we did was we went back to the DBA, showed them the SQL statement, showed them the results, and again showed them the transaction in process or in progress chart, and come to find out that work order ID didn't have an index on it. Right, so it was a very simple fix, very quick fix, but couldn't find it without a tool like NetData. Thank you very much for tuning in, and we'll catch you next time.